Hi, this is Gerardo Parra and my partner is Shaun and we are the Pellegrinos. This is our final demonstration of the EEG. So in last week's lab meeting, we demonstrated the end-to-end um, functionality of our EEG. We got our alpha filter to work as expected, but our beta filter was not, and some tweaks were necessary to get that working um, fully. And on the left-hand side, we have our head unit, and on the right-hand side is our base unit. And Shaun will go over some of the tweaks we made.
Yeah, just to reiterate, um, off of your advice, we measured the actual capacitance values and found that they were a lot off from their nominal values. So what we did is we inputted those capacitance values into our LT Spice simulations and then designed around there from the ground up. And so because of that, we just ended up redoing our circuit on another curve board. Another thing we found though was an issue was last week when our beta filter was going on. We found a halfway rectified signal come out. We just weren't getting VREF to our beta filter. And then another thing we did to improve our VREF on our base unit is we added two capacitors and it smoothed it out a lot and it worked much better.
So here we have a screen capture of our final schematic for the head unit. I broke it up into two different screen captures, one for the head unit and another one for the base unit. And on this next slide, we have the screen capture for the base unit. So this just carries on to the second half of our circuit. One thing I do want to point out, as Shaun mentioned, um, our capacitance values weren't accurate. Um, as you can see, as you can see on as you can see on our alpha filter, these capacitors should be 1 farad, but um, when we measured them out with a multimeter, they came out to the specific values. So we just used that in our uh, in our simulation to tweak our alpha filter as needed. And same goes with the beta filter. These capacitor values should be nominally 0.68 microfarad, but when we measured them, they came out to these specific values. And we included our fully updated Gantt chart. So we are in the final stretch, and we completed everything up until the final report. So that's something we will be working on and completing uh, before the deadline.
Yeah, so for our head unit, we just decided to apply our head unit PCB to the brim of a hat and it worked fine. It made it much easier to point the LED emitter, as you can see from the tip right here. And yeah,
And here's some pictures of our base unit and the enclosure. We just used a small cardboard box that we had, and we created some holes to fit the LEDs for the alpha and beta outputs to make it easy to see them flashing when they receive the signal.
yeah, the contrast on the black box helped a lot too. And then so here's a screen capture just showing our alpha filter with a frequency sweep from 1 to 60 hertz. We found that our center frequency, once we updated our capacitance and resistance values, was pretty much exactly what we expected, around 10 hertz. And we had a pass band around 8 to 12, which is exactly what we wanted.
Here we have the screen capture of our beta filter. Once again, we have a frequency sweep of 1 to 60 hertz, and we're seeing a center frequency just under 16 hertz, which was expected, um, depending or expected based on our simulation.
Yeah, and I just wanted to emphasize that this was end to end with the 50 millivolt input. All three of these screen captures, and then so for this final screen capture that we're going to show you today, it's just a side by side comparison showing that these kind of split up the frequencies pretty well. There's some overlap in around the 12 hertz range, but it's that's what we expected when we designed these.
Yeah. And now we'll show you a physical demonstration of our EEG. And yeah, thank you.
All right, so right here we're just going to be demonstrating the variation in our LED brightness depending on the signal. Right now I'm just turning on a 9 hertz signal, 50 millivolts. And then as you see, as I point it towards the light, our red light, the alpha one, is much brighter.
And next we will input a 18 hertz sine wave, 50 millivolts amplitude, as you can see here.
And now the green one is...
Now the green LED is much brighter than our red LED.
And just to show that a center frequency where they're both on, here's a 12 hertz. And they're about the same brightness. All right, so right now we're inputting a 15 hertz signal, and we're gonna show the variation in brightness as we go away. And just from a top view perspective, as you can see, it's a couple of hand distances away and still bright.
So here we are going to demonstrate that when we cover the IR receiver with a piece of paper, you will no longer see the LEDs blinking.
All right, so we have Jerry hooked up to the head unit right now with some homemade conductive gel that we made. Jerry, go ahead and stare down at it. As you can see, the lights are flickering. Jerry, look away real quick. And they die out. Look back. There they are again. And I'm gonna cover it now. As you can see, it dies out. And it's there again. And now we're gonna show you what we're getting on our actual EEG readings. So channel 1, which is the yellow waveform, are beta waves. As you can see, we have frequencies kind of in the 15 to 20 range for most of these parts. As I'm just quickly scrolling over as it repeats. And for our alpha waves, we're getting about 10 hertz for most of the waveforms. Jerry, go ahead and look away. All right, now look back at it again. Yeah, so in terms of amplitude, these readings are in the 0.7 peak to peak amplitude for our beta waves and about 0.3 for our alpha. Thank you.